Okay, linear programming, probably the hardest stuff we do all year, in my opinion. So the area of a parking lot is 600 square meters. A car requires 6 square meters. A bus requires 30 square meters. The attendant can handle only 60 vehicles. If a car is charged $250 and a bus $750, how many of each should be accepted to maximize income? So first thing you want to do is figure out your variables. So x is going to be my number of cars. Y will be my number of buses. Now we got to figure out my constraints. So objective is my income. I want to make the most money. So it's $250 for car and $750 for a bus. Then my 4 equations. 2 of them are almost always going to be x greater than or equal to 0 and y greater than or equal to 0, because that gives me in the first quadrant. It gives me that we're not going to have negative number of cars or negative number of buses. It's just not possible. Then the second thing, it looks like we're talking about how many vehicles it can handle. So x plus y, however many of each of these, has to be less than or equal to 60, because the attendant can only do 60 cars for vehicles. And then square meters. So how much square meters? So car takes up 6, I guess, and a bus requires 30, and I have a total of 600 square meters. So it's got to be less than that. So this thing, when I graph it, first I need to solve for my 2 equations. So my first equation, when I subtract x over, becomes that. My second one, when I subtract over 30y less than or equal to negative 6x plus 600, and then divide by 30, I get negative 1/5 x plus 20. So those are my 2 equations that I'm going to graph. So it looks like I'm going to go up, let's go by tens. 10, 20, 30, 40, 50, 10, 20, 30, 40, 50, if it went up just a little more, 60. So my first equation starts at 6, and if this one went a little more, it'd be 60 here. So it starts at 60, and then it's like down 1 over 1, down 1 over 1. So if I keep going, all it's going to bring me down to all the way to basically this 60 right here. So there's that equation. My other one starts at plus 20, and then it's down 1 over 5. Down 1 over 5. If I kept going, that would keep going that way. And they're both less than, so I'm shading below them. So kind of like my double shaded area is this little quadrilateral right there. That's going to be important. The 4 sides are like this. And I need to figure out those 4 points that makes up this region. So first one's easy, 0, 0. Second one, 0, 20. Third one, 0, all the way over here at 60, so 60, 0. And the fourth one is where they meet, and if you look close enough, they meet at 50, 10. You can also figure that out with substitution or elimination. So that thing. So now I'm looking at just these 2, and this gives me a maximum revenue. So if I have 0 cars and 0 buses, I'm making $0. If I have 0 cars, but I have 20 buses, so it's like 750 times 20, how much money am I making? I'm making $150. If I have 60 cars, but no buses, I'm making $150. And if I have 50 cars, 250 times 50 plus 750 times 10, so these 2 added together, I'm making $200. So obviously I want to make the most money I can, so my maximum income that I can get is $200, and that happens when I have 50 cars and 10 buses. Yeah, that's a long problem. Let's do one more. Example 2, it talks about a bike company makes two styles of bikes, the Traveler and the Tourister. So those are my variables. Traveler and my Tourister. And it says a bunch of information about them. So what I want to get down to is my revenue. How much do they make off each? So my Traveler makes $300. My Tourister gives me $600. There's my revenue. Again, my constraints always, almost always, those two are there. And then I'm looking at labor here. So I have frames and hours here. So it looks like each bike has the same frame and tires, but assembly and painting required for the Traveler is 1 hour, while it's 3 for the Tourister. So 1 for the Traveler and 3 for the Tourister, and I have 360 hours maximum to get, so it's got to be less than that. Second one says I have 300 frames, and it says they have the same frame, so that means x plus y less than or equal to 300. So, to graph this thing, I need to solve for y in both my equations. This one's easy. Y less than or equal to negative x plus 300. This one's a little more tricky, so when I solve, I get negative x plus 360. Then when I simplify, I get y less than or equal to negative 1/3 x plus 120. So when I graph this thing, let's go by 50, 100, 200, 300, 400, 500. Same thing here. 100, 200, 300, 400, 500. So when I graph this thing, the first one starts at 300, and it goes down 1 over 1, down 1 over 1, all the way down here to 300 again. My second equation starts at 120, so right in there. My slope is negative 1 over 3, so negative 1 over 1, 2, 3. Negative 1 over 1, 2, 3. If I keep it going, it brings me down like this. And they're both less than, so it's this, if I can get it, this shaded area in here. That gives it. So my four things that border that, so I got 0, 0. I got 1, 0, 120. That was that one. 0, or 300, 0. Then my fourth dot, it's not clear from the graph. So to figure that out, I need to do either substitution or elimination. So my equation, x plus 3y, 360, and x plus y, 300. If I multiply this bottom one by negative 1, turns all these negatives. Then when I add down, I get 2y equals 60, which means y equals 30. So it's going to be something 30. And if I go back to this equation, x plus y has got to be 300. So that would be 270 then. So there's my 4 dots. And then when I find my revenue, so always I'm making $0 here. If I do 600 times 120, I get $72,000. If I just make 300 of that one, I'm making $90,000. And if I make 270 of this and 30 of that, I'm making $99,000. So my maximum profit that I can make is $99,000, and that happens when I make 270 Travelers and 30 Tourister.